Chapter 1: Statistical Methods. Now, we talked about various methods of data presentation in Form 1 and 2, including simple line and bar graphs, comparative line and bar graphs, as well as divided rectangles. In this chapter, we'll look at 3 more methods of data presentation: compound bar graphs, proportional circles, and pie charts. Compound bar graphs. A compound bar graph is also known as a cumulative bar graph, a divided bar graph, or stacked bar graph. It is made up of 2 or more bars, which are commonly drawn vertically but can also be drawn horizontally. Each bar is segmented into multiple data sets on top of each other. Compound bar graphs are really a combination of comparative bar graphs and divided rectangle technique. If you remember this divided rectangle that we constructed for the tourism survey data, if you rotate it to stand vertically, we have a compound bar. If we had several bars drawn on an XY plane, we have a compound bar graph. Let's see how to construct compound bar graphs. We shall use this same tourism survey data to construct our compound bar graph. We shall have a bar for each year, so 5 bars. Each bar shall then be segmented into the respective countries. The first thing is to get the grand total for each year by simply adding the numbers. So 2014, the total will be 60,000. 2015 will be 65,300. 2016, it will be 70,000. 2017 will be 76,900. And 2018, the total will be 71,700. Now, using this grand total, we decide on an appropriate scale by considering the largest and the smallest values. Now, the important thing to remember is that the segment in each bar must be organized from bottom to top, starting with the largest to the smallest, or vice versa. But I prefer from largest to smallest. So let's start with 2014. The bar goes up to 60,000. We first arrange the data from the largest to the smallest. Then we add a new column called cumulative totals. Cumulative totals are obtained by vertically adding up the values of each country in successive steps. For example, the first cumulative total is 24,000. The second cumulative total is obtained by adding 24,000 plus 16,000, and that gives us 40,000. Third cumulative total, we add 40,000 plus 13,000, and that gives us 53,000. Fourth cumulative total, we add 53,000 plus 4,000, that gives us 57,000. And finally 57,000 plus 3,000 gives us 60,000. And so you see the last cumulative total gives us the grand total for that year. And now we simply plot the cumulative totals on the graph. So the UK, the US, Canada, China, and Germany. Then we go to 2015. First, we rearrange the data in descending order. And then we create a cumulative total column. First is the UK, 32,000. Secondly, 32,000 plus 14,000 gives us 46,000. Thirdly, 46,000 plus 13,000 is 59,000. Fourth cumulative total, 59,000 plus 3,800, that gives us 62,800. And finally 62,800 plus 2,500 That gives us 65,300. Then we plot the cumulative totals. The UK, Canada, the US, China, and Germany. We do the same for 2016. Here are the data and the cumulative totals. So we draw the bar. The UK, Canada, the US, China, and Germany. Same for 2017. The UK, Canada, the US, Germany, and China. Finally, 2018. Here is the data and the cumulative totals. We draw the bar. The UK, Canada, the US, Germany, and China. And that's our compound or stacked bar graph. Again, looking at this graph, you can tell that the UK was leading in the number of tourists who visited Kenya between the 5-year period, followed by Canada and then the US, with Germany being the least. However, the numbers in the leading countries were on a gradual decline, while those in the lagging countries were increasing slowly but gradually. The total numbers were lowest in 2014 and highest in 2017. And so, compound bar graphs provide clear visual impressions of the total values and are easy to read the highest and lowest totals at a glance by simply comparing the sizes of the segments. They are, however, quite difficult to construct, and the number of components that can be represented on a single bar are limited because long bars are difficult to compare. Next, we look at proportional circles. Now, proportional circles are drawn on maps to show quantities such as population, crop production, or mineral production in a given country. The size of each circle is proportional to the total value of the data it represents. They are very useful in comparing different total values as may be required. We shall use these data values for the population of 5 coastal counties: Kwale, Kilifi, Tana River, Lamu, and Taita Taveta as per the 2009 census. Proportional circles are drawn such that the radius of each circle is proportional to the square root of the absolute values. So we create another column for square roots of these figures. So we have 806, 1049, 490, 437, and 534. And now we choose an appropriate scale for the radius of these circles. If we had a scale of 1 centimeter representing 200 people, then the circle for Kwale will have a radius of 806 over 200, which gives us 4 centimeters. Kilifi, 1049 over 200 is 5.2. Tana River, 490 over 200 is 2.5. Lamu, 437 over 200 is 2.2. And Taita Taveta, 534 over 200 is 2.7 centimeters. Now all you need is to measure this radii with a compass and draw the circles on the map. You can then shade them differently to distinguish them. And that is how we do proportional circles. And just by looking at this figure, you can tell that the highest populated county out of these 5 is Kilifi, and the least populated is Lamu. Proportional circles can be combined with other methods such as pie charts to represent more information. They are, however, tedious to construct, and it is not possible to tell the actual total values. And finally, pie charts. A pie chart is also called a divided circle and is the most popular tool for data presentation. These circles are normally drawn and divided into segments to represent statistical data of individuals. Since a complete circle is 360 degrees, the total values are proportional to 360 degrees. Each portion is an angular proportion of the total value. So the angular value is given by frequency over total frequency times 360 degrees. For example, consider this population data for these 6 schools. If we wanted to draw a pie chart to represent this data, first we calculate the total population. That will give us 4,000. This 4,000 is equivalent to 360 degrees. So the angular value for school A will be 600 over 4,000 times 360, and that will give us 54 degrees. School B, 1,000 over 4,000 times 360 will give us 90 degrees. School C, 400 over 4,000 times 360 will give us 36 degrees. School D, 500 over 4,000 times 360 will give us 45 degrees. School E, 800 over 4,000 times 360 will give us 72 degrees. And finally, school F, 700 over 4,000 times 360 degrees is equal to 63 degrees. If you add the total angles, they will give you 360 degrees. Next, we draw a circle of any size. And we draw the first line. Using a protractor, we measure 54 degrees for school A. 54 degrees is around here. We remove the protractor and join that point to the center of the circle. So this is school A, 54 degrees. So we continue like that until we have all the 6 schools. And that is our simple pie chart.